Usually when we talk about a medical diagnosis, there's this expectation of absolute precision. It's almost like engineering. You break your arm, the x-ray shows that jagged white line, and the doctor just points at the film and says, well, there it is. That's the problem.
Right, yeah. It's incredibly binary. Broken or not broken.
Exactly. It's clean. But then you step into the world of advanced cybersecurity, and suddenly it feels like that x-ray machine is broken. Or worse, like someone is actively tampering with the film while you're trying to read it. We're looking at a diagnostic landscape that is just completely murky.
It is the absolute definition of muddy waters. You aren't just looking for a break. You're looking for a shadow that's actively trying to hide from you.
And that is exactly why we are here today. Welcome to the Deep Dive. Our mission today is to turn you into a cybersecurity master by exploring the core problem-solving logic and the highly technical assessment criteria for a very specific certification. We are diving into the NSE 6 EDRAD 7.0 exam.
Yeah, and it's a notoriously rigorous one, too. This exam doesn't just test if you can memorize a manual, it tests your ability to handle the platform in the heat of the moment.
Right, and just to set the stage for you, if you're taking the NSE 6 EDRAD 7.0 exam, you're looking at a 70-minute English language test. It's got about 30 to 35 multiple choice and multiple select questions.
And it's graded on a pass-fail basis, right?
Yep, exactly. Fortinet actually keeps the exact passing score a secret, so you really have to know your stuff. Okay, let's unpack this, because we aren't just going to read you a study guide today. We are going to step directly into the mindset of an elite security analyst.
I love that approach.
Yeah, so we've pulled 10 specific practice scenarios to understand the why behind the what's. And we're going to start right at the most terrifying, critical moment of a cyber attack. The first line of defense, containment, and eradication.
The absolute moment of truth.
Exactly. So let's jump into question 1. It goes like this. When an active ransomware threat is detected, which containment action should be taken? Option A, isolate the endpoint but keep the management connection. Option B, shut down the operating system immediately. Option C, delete all encrypted files and restore from backup. Or option D, format the hard drive automatically.
So many people get this wrong in a panic.
I bet. Looking at those options, I always think of this analogy. To me, option A is like putting a highly contagious patient in a hospital quarantine room with a thick glass window. You stop them from infecting others, but the doctors can still safely observe and treat them through the glass.
What's fascinating here is that your analogy is spot on. Option A is the ultimate containment strategy, and it is the correct answer. You isolate the endpoint to cut off lateral movement so the ransomware can't reach other servers, but you keep that management connection open. That's your glass window.
Right, so you can still figure out what happened.
Exactly. It lets your team remotely access the machine, pull memory dumps, and apply fixes. Now, if we look at option B, shutting down the OS immediately, that is a terrible response.
Because you lose everything in RAM.
Precisely. You instantly destroy volatile memory, you lose the malware's active connections, its running processes, and maybe even the encryption keys temporarily stored in memory. You've just blinded yourself.
Wow, okay. What about option C? Deleting the files and restoring from backup. That sounds like a quick fix.
It's an illusion of a fix. If you just wipe the encrypted files and restore, you completely bypass the investigation. You have no idea how the ransomware got in, which means the attacker's back door is still wide open. They'll just encrypt your restored files tomorrow.
Oh, that's a nightmare. And option D, formatting the hard drive.
That's the nuclear option. It destroys all forensic evidence. You're killing the patient to cure the disease. So A is definitely the only correct path.
Okay, so if we've successfully contained the device using option A, what actually happens to the malicious code running on it? Let's look at question 5. What does a terminated status indicate for a malicious process? Option A, the policy successfully stopped the process and actively removed it from memory. Option B, the malware crashed unexpectedly. Option C, the user manually closed the application. Or option D, the process is temporarily paused but remains in memory.
This is a great question because it tests how you interpret the dashboard. The correct answer is option A.
So it's a controlled action by the platform.
Exactly. When you see terminated, it means the automated policy caught the threat, blocked it, and surgically ejected it from system memory. It stopped cold.
Which means it's not a crash like in option B.
Right. A crash is an uncontrolled system error. Terminated is deliberate. And option C is just wrong because, malware doesn't give users a convenient little X button to click to close it.
Good point. And option D,
If the process were just temporarily paused, like D suggests, it would still be sitting in the system's memory, which is incredibly dangerous. So A is the only right answer.
Okay, so containing threats and terminating processes relies on the EDR software actually functioning properly, which brings us to Section 2, the silent watcher, agent health, and invisible threats. Because if the agent isn't healthy, you can't see anything. Let's look at question 4.
Let's do it.
What causes a FortiEDR collector agent to enter a degraded state? Option A, the operating system is installing a routine update. Option B, the logged-in user lacks administrative privileges. Option C, the endpoint was recently isolated from the network. Or option D, the agent is missing required OS permissions or a core component failed to load.
The degraded state is one that makes analysts very nervous. The correct answer here is option D.
Missing permissions or failed components.
Yes. A degraded state means the software is running, but it's fundamentally handicapped. It can't hook deeply into the system, meaning your visibility is compromised. It's awake, but effectively blind in one eye.
Why isn't it option A? Like, wouldn't a Windows update cause issues?
An OS update might temporarily pause a service, sure, but it doesn't trigger a permanent degraded health state in the console. And for option B, EDR agents run at the deep system kernel level. They literally don't care if the human on the keyboard is an admin or a standard user.
Oh, interesting. And option C, the isolated endpoint.
We just talked about that in the first question. An isolated endpoint is a successful security action. The agent is still perfectly healthy. It's the network that's restricted, not the software. So D is the right answer.
That makes sense. But here's where it gets really interesting. What if the agent is perfectly healthy, it has all its permissions, but the malware doesn't even have a file to scan? How does a healthy agent catch a ghost? Let's read question 6.
The ghosts.
How does FortiEDR effectively detect fileless malware? Option A, pre-execution signature scanning of the hard drive. Option B, post-execution behavioral analysis of running processes. Option C, static extraction analysis in a sandbox. Or option D, perimeter network filtering before the payload enters.
Fileless malware is wild because traditional antivirus completely falls apart here. It operates entirely in memory. It never writes a physical file to the disk.
So if there's no file, option A is outright.
Completely. You can't do pre-execution signature scanning on a file that doesn't exist, which is exactly why option C is wrong too. If there's no physical binary on the diff, you have nothing to extract and analyze in a static sandbox.
What about option D, the network perimeter?
The firewall might catch the initial delivery trick, like a bad link in an email, but once the fileless payload is running purely in the laptop's memory, the perimeter filter is blind to it. It only sees network traffic.
So it has to be option B.
Yes, option B is correct.
Yeah.
Post-execution behavioral analysis. You let things run, but you monitor how they run. If a standard calculator app suddenly opens a command prompt and tries to alter the registry, the behavioral analysis flags it as malicious immediately, catching the invisible threat.
Wow. Okay, but since you brought up the perimeter and firewalls, that takes us to section 3, broadening the horizon, network integration, and passive discovery. Because like you said, EDR doesn't operate in a vacuum.
If we connect this to the bigger picture, EDR relies heavily on the wider network tools.
Let's hit question 3 on that exact topic. What is the primary benefit of integrating FortiEDR with a FortiGate firewall? Option A, offloading endpoint behavioral analysis to the firewall hardware. Option B, allowing secure bypasses of web filtering policies. Option C, enabling automated quarantine of compromised endpoints at the network level. Or option D, replacing the local endpoint firewall entirely.
It's crucial to understand how these tools talk. The right answer is option C, automated quarantine at the network level.
So they team up.
Exactly. If the EDR detects a severe threat on a laptop, it instantly tells the FortiGate firewall, hey, this IP is compromised. The firewall then blocks that device from reaching the internet or jumping to other network segments. The EDR fights the fire inside the house, and the firewall builds a moat around the house.
I love that. So why is option A wrong? Can't the firewall help with the heavy lifting?
No, firewalls and EDRs are fundamentally different. A firewall cannot monitor local endpoint memory. You just can't offload behavioral analysis to it.
What about option B, secure bypasses?
You never, ever integrate security tools to create loopholes or bypasses. That's terrible practice. And for option D, FortiGate integration adds a layer. It doesn't replace the local endpoint firewall completely, so C is the clear winner.
Okay, if the firewall and EDR are talking, what about devices that aren't running an EDR agent? Let's say I bring my personal phone into the office. Let's look at question 7. How does FortiEDR discover unmanaged devices on the network? Option A, forcing all devices to register through a captive portal. Option B, performing deep credentialed scanning of network subnets. Option C, using EDR collectors to passively observe broadcast and neighbor discovery traffic. Or Option D, monitoring Active Directory domain controller login logs.
This is one of the most elegant features of the platform. The correct answer is option C.
Passive observation.
Yes. The EDR collectors, the agents already installed on your corporate laptops, act as silent listeners. Devices on a network are constantly yelling out broadcast traffic, saying, "Here I am." The managed laptops hear that ambient noise, realize it's a new, unmanaged device, and quietly report it to the console.
That is brilliant. Why not use Option A, the captive portal?
Captive portals are intrusive. They disrupt the user workflow. And option B, deep credentialed scanning, is practically impossible because you don't have the login credentials for every random smart TV or guest phone on the network.
And Option D.
Active Directory logs only show devices that actually authenticate to the Windows domain. A rogue smart fridge is not logging into your domain controller, so C is the only way to do this smoothly.
Okay, so we have forensic dumps, behavioral alerts, passive network listeners. This is a mountain of data. Where does it all go? That leads us to Section 4, the brains of the operation, core architecture, and telemetry. Let's read question 8.
Let's hear it.
What is the function of the core component in the FortiEDR architecture? Option A, it processes event data and manages the central database. Option B, it acts as the local agent installed on workstations. Option C, it provides hardware-level network load balancing. Or Option D, it solely handles the graphical user interface.
The architecture is critical for the NSE 6 EDRAD 7.0 exam. The right answer is option A.
It processes the event data.
Exactly. The core is the central processing unit of the entire infrastructure. It ingests the telemetry from thousands of endpoints and manages that central database.
So it's not the local agent, which is Option B.
Right. The local agent is called the collector, not the core. And option C is wrong because load balancing is a standard networking function handled by dedicated hardware, not the EDR core.
And what about D, the user interface?
The user interface is handled by the central manager component. The core is purely the data crunching engine room.
Okay, so once the core has crunched all this data, how do we actually hunt with it? Let's check question 10. Which type of data is utilized in the threat hunting module to trace advanced persistent threats? Option A, marketing campaign performance metrics. Option B, physical building access badge logs. Option C, granular endpoint telemetry such as registry changes and process creations. Or Option D, annual security compliance surveys.
I mean, I hope the wrong answers here are a bit obvious.
Yeah, I hope so too.
The correct answer is option C. To trace a sophisticated, slow-moving digital adversary, you need absolute granularity. You need a searchable database of every process creation, every registry change, every file modification.
Which means Option A is laughable. You can't catch a hacker by looking at the click-through rate on a newsletter.
Exactly. And option B, building badges, tells you who walked through the front door of the physical office, but advanced persistent threats are almost entirely digital and remote.
And Option D, administrative surveys definitely won't trace a live cyber attack. So C is the only logical choice.
100%.
But hunting through all that granular telemetry takes time. Which brings us to Section 5, the proactive human element. Let's look at question 2. What is the purpose of scheduled queries in FortiEDR? Option A, generating weekly PDF reports on user productivity. Option B, continuously monitoring the environment for indicators of compromise over time. Option C, automatically updating collector agents to the latest software version. Or Option D, syncing user accounts with Active Directory.
Threat hunting shouldn't just be something you do manually once a month. The correct answer is option B.
Continuous monitoring.
Yes.
All right.
You write a query for a specific stealthy threat indicator and you schedule it to run constantly. You're setting a persistent tripwire to catch things over time.
So it's not Option A. We aren't doing HR surveillance.
No, EDR is a security platform, not an employee productivity tracker. And it's not for IT administrative tasks either, so option C, updating software, and option D, syncing Active Directory, are completely incorrect uses of the threat hunting module.
So what does this all mean when a legitimate tool suddenly looks bad? Let's say that tripwire goes off, but the tool that triggered it is completely approved. This is question 9. What is the appropriate response when a legitimate administrative tool triggers a behavioral alert? Option A, immediately wipe the machine to prevent a potential breach. Option B, ignore the alert completely because the tool is approved. Option C, delete the administrative tool from the network entirely. Or option D, investigate the parent process and user context to verify authorization.
This is an everyday reality for analysts.
Right. To me, it's like being a traffic cop and seeing a police car speeding. It's usually fine, but you have to verify it wasn't stolen by a joyrider.
This raises an important question about context, and that's why option D is correct. You investigate the parent process. Was it launched by an actual admin during business hours, or was it spawned by a malicious macro in a Word document?
So you don't just wipe the machine like option A says.
If you wipe the machine every time an admin opens PowerShell, you destroy your company's productivity. It's a massive overreaction.
But you also can't do option B and just ignore it.
Right, ignoring it is dangerous. Attackers actively seek out these admin tools to blend in. It's called living off the land.
And option C, just deleting the tools from the network.
If you delete the tools, you break your IT operations. System administrators need those tools to do their jobs. So D is the only responsible action.
That makes total sense. Well, thank you for joining us on this deep dive. Keep questioning the data, keep looking for the context, and we will see you next time.